Welcome to lecture series 8051 Microcontroller. In today's session, we will discuss about the special function register SCON format along with how to interface 8051 with some serial devices along with some simple programs, or how to we can transmit the data. So, first we will discuss the SCON format. SCON format, which is a serial control register, which will give the informations about the serial transmission. So, for that we have a 8-bit positions. The first one is DI, the SCON register having the 8-bit format. The D0 position, which is RI. RI is receiver interrupt. Whenever the data is filled or received, the received data is stored in the SBUF. Okay. So, the data is filled in the SBUF. So, when the SBUF is full, at the end of 8th bit we are receiving the stop bit. So, at the halfway of the stop bit, this interrupt will be 1. The interrupt RI is 1 means what it indicates, the SBUF is full. Okay. The next bit position is TI, which is a transmitter interrupt. This will which indicate when the SBUF is empty. When the SBUF is empty, it will raise the interrupt. So, it raise the interrupt means it requests the controller to load the data for the successive data. Okay. So, whenever the buffer is empty, the transmission over. So, next byte to be load in the SBUF. The receiver interrupt is the received data is stored in the SBuffer. Now, it requests the controller to read the data. Okay. So, this is for the write operation, RI for the receive operation. The next 2 bits which are represent the RB8 or TB8, which will give the 9th bit positions in the mode 2 format. Okay. Whenever the interrupt is occurred, then the bit positions will be set. This is a receiver enable, additional bit position is used. Whenever the bit is 1 means it receive the data. Okay. If you are giving 0, then it will disable the receiver. Then SM2 is not used, these two are used for selecting the modes. So, based on the 2 bit positions, it will support the mode 0, mode 1, mode 2 and mode 3. So, 3 different modes it will support. Now, we will discuss each mode operations. Mode 0, mode 0 is named it as a shift register mode. Here the baud rate is fixed because the constant frequency only we are applying. So, whatever your system clock frequency, that will be divided by 2 because the generated clock frequency for the single machine cycle. So, that is divided by 12, we get a 1. Suppose your clock frequency you are considered as 6 megahertz means, then you will get it as a 500 kilohertz. So, this way we are using this mode is a this is a wave representation how the signal are transmitted. Here the transmitter received data will be either via the external signal via the either shifted out or shifted in. Shifted out means it will give the right shift, this one is left shift. Okay. So, either the right shift or left shift will be occurred based on the clock frequency. Here the received data is used for generating the clock frequency. So, based on that the data will be either shifted out for transmitting data, shifted in for receiving the data. So, during that the rising edge is used for shift the operations. In this shift operation, the S3, S4, S5 will be low. Okay. Then S5, S1, S2 will be high in the mode 1. So, these are the 6 states in the machine cycle. So, during this mode 0 operations, this will be low and high. The next one is mode 1, which is called it as a standard UART mode, because most frequently we are using this mode. Here we are transmitting the 8 bits plus start and stop bit. So, totally 10 bits. So, 10 bits are used as a frame size. Okay. So, the start bit is always low, stop bit is high. So, totally this is a one frame. Okay. So, this way we are transmitting. Here how we are calculating the baud rate means the 2 power s mode, whether we are using the single or double, it might be either 0 or 1. So, any one of the value divided by 32D into the oscillator frequency is system frequency divided by 12. The D represents the decimal number. Okay. The 12 is a number of pulses in the machine cycle. The 256 minus the given value, whatever in this TH1 loaded value, then you can calculate the baud rate for the mode 1. We will explain the same thing by writing the program. Okay. And the another one is mode 2, which is a multiprocessor mode. In the multiprocessor mode, we are transmitting the 11 bits as a frame. Here 8 bits plus 1, 9th bit is added. The 9th bit is what represents in the SCON format is either RB8 or TB8, right. So, that positions. When it is 1 means what it indicates externally the received interrupts. Whenever the interrupt are received, then it will be 1. If it is 0 means there is no interrupt are received. So, based on that RB8 value will be that is during the transmission the TB8 value will be loaded. During the transmission the DB8 value will be loaded as a 9th bit. During the receiving the 9th will be loaded in the RB8. Okay. Then additionally the start and stop bits we are using. Here how we are calculating the baud rate means 2 power s mode divided by 64 into oscillator frequency. Mode 3 it is similar to mode 2, but the baud rate is different. It is the baud rate is like a mode 1. Okay. So, most frequently we are using the mode 2 and mode 1. Now, we will start how the transmission will starts, right. The 8051 want to transmit the data. What we are thinking here 8051 we have, right. Within that we have one of the pin TXT, right. Via this TXT we are transmitting the bit. So, this way only we are thinking. So, within that how the data is transmitter or what are the processing are involved in this. Transmitter here it will perform as a series data, okay, but the processor is a parallel one. So, how the parallel data will be moved to the serial one. So, what suppose you have the data in port 1, the port 1 data you want to transmit, then the port 1 data which is a parallel data will be moved to the parallel to serial converter. So, the serial converter what it will do, the data which is D0 to D7, D0 to D7 will be converted into D0 to D7. So, this is a serial data. After converting into serial, this will be loaded into the S buff. Now, the S buff after getting that, then start and stop bits are added. S buff content which is a message along with start and stop bits are added. This 10 bits only transmitted via the TXT signal. Okay. So, this is a transmission process. First the port the data, whatever the data is available, or you can sense the data from the external switches. Suppose here the port 1 I will connect it via the 8 switches. Based on the switches the signal will be recognized, then it will be converted into serial, then stored in the buffer, then converted into frame, then we are transmitting the data. Now, we will discuss about how we are receiving the data. So, receiving means automatically we are receiving via the RXT signal. So, in the RXT signal the received data which consists of the start and stop bit. Start and stop bit D0 to D7 we have, right. So, we have to remove the start bit and stop bit, only this D0 to D7 will be loaded in the S buff, the 8 bit content. So, this 8 bit content which is in the serial format we cannot directly given to the microcontroller. So, it is converted into parallel, now it will be loaded. Suppose you want to store the data in P2 means you can store it, or any one of the register you can store it, right. So, the received data of in the form of frames we have to remove the start and stop bit, only the D0 to D7 the exact message will be loaded in the S buff, right. From that it will be converted into parallel, then we are moving to the microcontroller for further process. This is a simple structure how the trans receiver in 8051. So, the 8051 have 4 ports, we are considering only 2 ports, one is for input, another one for output. So, the input is connected via the switch, output is connected via the LEDs. Okay. Then we have 2 pins which are transmitter and receiver. Suppose externally if the data is received and want to transmit. Okay. So, externally received what is nothing but 8 switches are connected. If any one of the switches are pressed or single switch also you can use it with a continuous 8 pulses you can give it. So, the sensed or read the signals from the switches via the port 2. This port 2 signal is moved to SBUF, right. From the SBUF it will be transmitted. This is a way, one way. Suppose if you are receiving any one of the signal, received signal move to the SBUF, SBUF to P1 you are transmitting, pausing. In the P1 you have the LED, that LED, suppose if you have 8 LEDs that will be glowing based on the number of ones and zeros. Okay. So, either you can read the signal from the switches or you can transmit the signal to the LED. So, before writing the program we have to know how to calculate the baud rate. So, here we have every system with a different frequency which is a crystal frequency, right. In 8051 we are considering for 11.0592. So, with this frequency which is a machine cycle frequency, this is a frequency for one machine cycle which consists of 12 pulses. So, we have to divided by 12 will get a clock frequency for the single pulse. That single pulse will be divided by either 32 or 16. If it is 16 means you can get the double baud rate, if it is 0 means the actual value you will get it 28,800 hertz which will define the baud rate. After that what value you want to move it that into the TH register. Okay. This value only divided by this, then its corresponding hexa equivalent we are loaded after subtracting. Okay. If it is in mode 0, if you have the value was 9600, if mode equal to 1 means that value will be doubled. Okay. So, likewise this is a normal mode of operation, by setting S mode whatever the assigned baud rate will be doubled, that is the advantage which will be activated by using the peak-on register. Suppose I ask you to calculate the baud rate for 1200, what is the frequency for that? So, already we have the system clock frequency divided by 12, then again divided by 32, we are getting 28,800, right. So, now our value which is given to your system is 28,800 hertz, that will be divided by 2400. So, what you get, the value was 12, the 12 FF minus 12. So, 12 means it is a decimal value. So, convert into hexadecimal C, you subtract with C, then you will get the value as F4. Okay. The F4, or you can say 256 minus 12, what is that 442. This is a baud rate for this. Suppose I am asking for 9600 means 28,800 divided by 9600. So, whatever the values comes, that pulses should be subtracted from the 256, or you can subtract from the FF. So, this way you have to calculate the required frequency for your design specification. Now, we will discuss how to write a program for transmitting a particular number. Suppose I want to transmit the number 77 in serial communication, right. So, how I will convert this 77 as a frames, then I want to transmit. So, this is a way, now we know how to frame the words, right. So, what you will do, 77 along with the start bit is always 0, stop bit is 1, right. So, this format 77 means 1, 0, 1, 1, then 0, 1, 1, right. So, this is a start bit, this is stop bit, then these two are the 77. So, for this high value, then low value, then high, 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 then low, then goes to high, 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 then goes to low. So, this pulse, this is a frame. So, this frame I want to transmit. Suppose you are taking in the CRO, you will get the same value. So, write a program to transfer the value 77, but instead of that, this signal, this pulse to be transmitted via the P 1.4. Okay. So, additionally what they have given, put 2 highs at the start and 2 high at the end point. Okay. So, they have specified, so no need of this 0. So, here you put 1 1. So, one more 1 and 2 ones are added. Okay. So, after that 2 highs will be added. So, for this first 2 high, then 1 low, then 3 high signals, then 1 low, then 3 high signal along with the 2 start bits. Okay. So, this pulse I want to get it in the P 1.4. So, LSP first the same way only we also written the wave. So, now we have to think how to write the program. So, what we have to do, first we have to load the data. So, the 77 is moved to accumulator, right. The first data is loaded in accumulator, then the 2 points should be start. So, these 2 start bits I will give it as set bit 1.4 1.4. Then how many bits I am going to transmit? 8 bits, that is why I have given the counter value as 8. Then the given value 77 is moved to accumulator, right. The accumulator now rotating right. So, rotating right with the carry means first bit will be transmitted. So, bit by bit the was transmitter via the carry. So, the carry flag will move to the P 1.4, right. So, like that what you have this kind of informations you have, right. So, for these 2 already we are transmitted. So, now only these 8 bits I am going to transmit. Suppose carry flag means the first LSB will becomes, it was set, then it was moved to the P 1.4. So, P 1.4 now become 1. Then the counter value is reduced as 7, then again we are repeating now one more rotating right. So, you will get the value as 1, then you will get it as 1, then it is reduced as 0, now we are getting the next 1, then we will get the value as 1, then it is reduced as 5, the next bit 0 is received, then the 0 is transmitted, right, the first 4 bits. Then again it was reduced to 4, the next 1, then 3, 1, right, the 1, 1, 1, 0. At the time the value was 1, now it reduced to 0, if the 0 means it exit from the loop. Now, for the stop bit we are setting P 1.4 as a 2 high, end point also we have to set it as 2 high, that is why these 2 set and receiving points we have given. Okay. So, any kind of numbers we can transmit, first we have to load in the accumulator, then initialize the counter, then rotating right or left. In LSP first means you have to use the rotating right. In case of MSB if they were specifying, then you can use the RLC left, right. Then which port have they specified, only we are reading the carry, via the carry only we are moving, then the process is repeated till the 8 bit. Next program we will discuss, write a program to receive in a byte from a switch of data serially via the 1.1, right, port 1.1. That is what it states, port 1.1 here, 1.1, the data to be stored into the R1 register. So, in this we are receiving and store it as a frames, then either a single switch you can use it with the 8 times you are pressing. 8 pressing means suppose first 3 times you are pressing as low, right, then remaining as high. So, this value only you are giving. So, first 4 ones, then this value. So, if you are reading in the LSB value, then what you were do it like this. So, this data you have to read it and store in the value of R1 register. So, for this how you are planning to write the program. So, first I have to clear the accumulator, because any process will be performed via the accumulator, because this is a receiving process. In case of transmitting we are loading the data, this is a receiving. So, clear the accumulator. Then how many bits you are planning to receive? 8 bits. So, I initialize the 8 bit as a counter value. Now, from the switch, here I have connected the switch. So, this switch is read. Suppose if I have open means the value 0 is moved to the carry, right. Now, how the performance is like this, this is accumulator register. this is a carry, right, rotate right. So, after pressing that P11 value, now the value is 0 means the 0 is recognized, the 0 will be loaded in the 7th bit. Then this way we are writing, the first sensed data will be moved to the carry is inserted in the MSB side. Okay. So, then the bit is reduced as a 7, then again we are moving, now the pressed value is 0. So, again the 0 is moved, right. Automatically the data is initially all values are 0 0, right, in the accumulator. Now, I am inserting the 0. So, 3 zeros are inserted, I will consider the same as. So, after that in the value is 4 means I have pressed the value of 4. So, now the value is 1, or you consider the number as 1010, alternative on and off, right. Now, I have pressed the switch, so the switch is closed. Switch is closed means carry is 1. Carry is 1 means carry is inserted in the MSB. Now, the remaining bit positions are shifted as 1. Okay. Now, the counter value is reduced as 7. So, again I am repeating the process. Now, again checking the switch. Now, the switch is open. Open means 0 will be inserted. Now, the carry value is 0. So, what will happen through the right shift, then 0 1 0 0, right. Another I am pressing the value as switch. So, alternatively the 1 will be entered, then it will be shifted, right. Then again I am opening the switch. So, 0 will be entered, 0, then right shift 1 0 1 0 0 0. So, this way the process will be repeatedly comes till the counter reach 0, 8 bits. When the counter reaches 0 means whatever the value in accumulator, alternate bits mean automatically we are expecting 0 1 0 1 0 1. So, this value will be available in the accumulator, that is moved to the R1 register. Okay. So, clear the accumulator, initialize the counter value, read the switch via the carry, then we have to rotate the accumulator via the carry means automatically the carry flag will be entered via the MSB. After 8 rotation you will get the first pressed data in D7, bit position in D7, the last one is in the D7. Once the counter reaches 0 means it will exit from the loop. Now, the available accumulator value is read from the switch is moved to the R1 register. Now, I want to transfer the letter. First I have transmitted a number, right, without any specification of the baud rate. So, simple program I have written. Here in this program that letter is given, I want to transmit the letter J with a specified baud rate. Okay. So, now what I have to do? First I have to identify the ASCII value for the J, right. Then I have to activate the baud rate. So, for that how we are calculating the baud rate? Yes, baud rate should be initialized via the timer 1. The baud rate how we are calculating means 28,800 divided by 4,800. Okay. So, the 28,800 divided by 4,800 the value is 6, right. So, the 6 is FF minus 6, this value, that is what is the value F9, F9H should be loaded in the TH1. So, the TH1 if you want to load it, before that you have to activate the timer 1, this is auto reload. So, mode 2. So, mode 2 with the auto, mode 2 in timer 1 we have to load it. So, for that I have the register format. So, timer 1 means this is 4 bits for timer 1, this 4 bits for timer 0. So, here I have to give it the value as 10, right. Here I am use it as a timer. So, remaining all signals are 00. So, I will read this value as 20H. So, 20H should be loaded in the T mode, then only the TH value will be loaded as a F9. Then the baud rate I have calculated as F9. Then SCON I have to initialize with the 8 bit. 8 bit means this 2 bit will be 0, then I have to activate the renewable, right. In case of mode 0, mode 1 if I have selected 01 I will give it. So, the value is 50 with mode 1. Okay. Based on the specifications, you put zeros and ones and find the value, then you move into the program. Then everything is initialized, right? T mode is activated with a decimal value, counter value, then SCON also activated. Now I have to start the timer. Start the timer means what we are using, timer 1 I have used, right? So set bit of R1. So after that, once the timer start means I have to load the value SBUF, which is our required value J. Its corresponding ASCII equivalent is 74. So 74 is a binary value will be loaded in the SBUF. Now it started to transmit till the timer TR become reset. Once it is set means then we have to TF. So this is a program for that. Already we have calculated the T mode, which is 20, right? 20, which is written here. 20 is written. Then the baud rate we have calculated as F9, that is initialized in the TH1 comma F9. Then SCON is calculated, which is 50 H, that was loaded in 50, right? These three you have to calculate and do it. Then I have to start the timer. So set bit timer 1, it started. Now the required data, what you want, that is moved to the buffer. Now I am transmitting the data till the transmit interrupt till set, I will repeat the same process. So bit by bit all bits are transmitted. At the end of stop bit, automatically this interrupt will be rise. Once this is set means it will exit from the loop. So after exiting, I am clearing the TI. Suppose further you have a successive data, you can clear it, otherwise you can stop it and exit it. Okay. In today's session, we have discussed about the format of SCON register, then how to transmit the number or a specific characters. Okay. So for this kind of transmissions, first you have to know how to activate the timer mode, because we have to activate the baud rate, calculate the baud rate, that should be loaded in the TH1. So to use the TH1, we have to activate the timer 1. That's why we have to use the timer mode and the TH. Both are for giving the baud rate. If the no baud rate means no need to specify this. Then SCON you have to activate, then we are giving the SBUF value, that is whatever you want to transmit or receive, that should be loaded in the SBuffer. That is why we have to activate. Via the accumulator only we are performing. So SBUF you activate, then transmit it. Okay. So along with that we are adding the start and stop bit, right. So in the start bit we are usually reading, and after deleting the data we are started to load the D0 to D7. Then D7, after that we are adding the stop bit. The stop bit always recognized with the half of the passway, right. Instead of immediate recognition, after passing the half pulse, then only we identified and we activated either the TI or RI, because it is used to self noise reduction. By using that we can strengthening the signal quality by the, it also act as a noise immunity. Okay. That is why we are using the halfway of the stop bit. So with this I will wind this session. Thank you.